Okay, bachcho, welcome back. Now we are going to do one more numerical, which is based on de Broglie's wavelength and Einstein's energy relation. Okay, for photon. So the question is, compare the energy of a photon. So we have to compare the energy of a photon and a neutron. And the given is they both have a wavelength of 1 angstrom. Okay, so energy of a photon. So let's write energy of a photon first. So what do you know about energy of a photon? So we all know the relation E equals to h nu, right? H into frequency. So this relation we know, and we also know that nu frequency is can be given as c by lambda. So nu photon, if you are talking about photon, so this relation also we know. Okay. And do we know anything about this lambda? Yes. So C is 3 into 10 to power 8 and lambda P is given as 1 angstrom, that is 1 into 10 raised to power minus 10 meters. So this is 1 angstrom. This is given. Okay, so this part we have whatever we knew, we have written it here. Okay. Now we have to talk about the neutron. So what do we know about neutron? So we know that mass of neutron is 1.67 into 10 raised to power minus 27 kg. And what about the energy? So this is what is asked from us. So we have to get the energy of neutron. This is what we need to find out. Okay, so I will keep it like this. And what else is given is lambda of neutron is given as 1 angstrom. Yani it is given as 10 raised to power minus 10 meters. And do we know anything else about lambda of a neutron? So it is a matter particle. So lambda of neutron must be equals to h upon p of momentum of neutron. Therefore, momentum of neutron can be given as h upon lambda n. So these are the things that I know. Okay, so what I have done here is I have written everything that I know about whatever is given in the question. I don't know how to solve this numerical right now, and no one actually knows. So I am going to help my brain to look at all the information now and to find out the required answer. So I have to find out this energy of neutron, and I have to find out energy of photon. This is also not known right now. So I have to find out energy of neutron and I have to find out energy of photon, and then I have to compare them. Okay, so now the information that I have, I will try to use that to find out these quantities. So energy of neutron is the formula that we can use here is kinetic energy can be given as p square by 2m. So if I find out the momentum of neutron and mass of neutron, I can get its energy. What about energy of photon? Okay, if I find out h, I already knew, and if I find out mu, that is frequency, so I will find out the energy of photon too. So energy of photon can be found out from this formula from here, right? So let's because we have to compare the energies, so let's write it like energy of photon by energy of neutron. This can be given as energy of photon is h into c by lambda of photon by energy of neutron is given as Pn square. Okay, so Pn square is h by lambda of neutron and this is going to be squared by twice into m into n. Okay, so what I can do is I can expand it. I don't want to solve it right here because I can see that some quantities are going to be get cancelled. So I am writing it as h into c, and this 2mn, this will come to the numerator. So this will be 2 into mn. Take another color. I will take red one itself. So 2mn by, so what do we have here? There is this lambda p, and I have this h square, and this lambda n square, it will go up here. And because they both have same wavelength, we have given lambda neutron equals to lambda photon equals to 1 angstrom. So one of the square is going to cut by this. So energy of photon by energy of neutron can be written as, okay, one of the square of h is also going to get cancelled by this h. So I have c into 2 into mass of neutron by, and this lambda, one of the lambda n is here, by h. Okay, so I have this value. Now I am going to, now I am going to put the values. So ep by en, and this is photon. So c is 3 into 10 to the power 8 into 2 into mass of neutron is 1.67 into 10 raised to the power minus 27 into lambda n is 10 raised to the power minus 10 by, I have h, that is 6.6 into 10 raised to the power minus 34. So this ratio is going to come out as, okay, let's check what I can cut from here. So 3 and 2, 6. Okay, 6, 3 and 2 and 6 can be cut. I am going to get an approximate answer. So 6 get cancelled by this 6.6, and because I have cut it a larger number from 6, I am going to reduce this number and write it as 1. Okay, so this is going to be 1, and actually 1 is quite 1.67. I am going to write it as I'm going to write it as 1.5 actually. I'm going to write it as 1.5 into 10 raised to power. I have 8, this 8. I have minus 27 and I have minus 10. So 8 minus 27 minus 10, and this 34 will come up. So plus 34. So what do I have here? I have E photon by E neutron is going to be 1.5 into 10 raised to power. So I have 8 and 34 is 42 minus 37. So EP by En, I am going to write it here. So EP by E photon by E, energy of photon by energy of neutron is going to come out to be 1.5 into 10 raised to power 5, something like that. Okay, so for same de Broglie wavelength, the energy of photon is going to be about a million times, or 0.1 times, 0.1 million times higher than the energy of neutron. Okay, so thank you. I will see you in the next lecture.